X is a normal distribution with a mean of 15 and a variance of 6.25. And so the mean is 15 and the standard deviation is the square root of 6.25, which is 2.5. We want to find k if the probability of x being bigger than k is 0.7. So this would be 15 here. And we know that this is perfectly symmetric. So we've got some value k here such that the area in this direction is 0.7. Now, we can find this using an inverse normal. So what I'm going to do is bring in the calculator. And we use the inverse normal when we know the probability, but we want to find the value. So if we go to interactive continuous, and this time we want inverse rather than continuous, and it's inverse normal CDF. Now it's asking us about the tail setting. That's why I drew the diagram. We can see that the values we want are to the right. So that is going to be a tail setting of right. The probability is 0.7. Our standard deviation was 2.5 and our mean was 15. And that tells us that the value of k here is 13.69. So that's the answer to part A. Now for part B, probability x is bigger than k is 0.25. Well, that's less than a half. And so we know that k is going to be on this side and the tail would be down here. So it's going to be a right tail. The probability is 0.25 this time. I'm just going to edit this one that I've already got. And that tells me that k is 16.69. And then finally, we want the probability of x being less than k is 0.1. So this is 15, k would be here, and this area here would be 0.1. So when we go to the inverse, this time we'll leave the tail setting as left because the area we want is on the left. We've got 0.1 and we have 2.5 and 15, and that is 11.80. Now, alternatively, we could find that using a normal CDF. What we could do is we could go for a solve, and 0.1 equals, and then if we go for the normal CDF, the lower here would be negative infinity. The upper we don't know, so let's call it x. The sigma was 2.5 and the mu was 15. And we click OK on that, it gives us the same answer, 11.80. So we can do it with a solve as well.